Okay, so here's the bonus. What if we used integration by parts? Is it possible? I tried it. I don't think so, but let me show you guys what I end up with. And in fact, if we do integration by parts with this integral, I cannot solve this integral, but I actually get something else. So it's kind of funny. Let's take a look though. So instead of integrating it, let me try to differentiate it first. So that's the idea of the integration by parts, right? One part to be integrated, the other part to be differentiated. So I'll do the di plus minus here to get ready. I will differentiate this 1 over square root. It's the same as negative 1/2 power. So we look at this as x squared plus 16 raised to the negative 1/2 power, and we'll integrate 1. Okay, do the power rule minus 1 and also the chain rule. But let me put this in the front first. Keep this. Negative 1/2 minus 1 is negative 3/2, and we multiply by the derivative of the inside, which we need 2x here. And then integrating 1, we just get x. So right here, we can simplify this a little bit before we move on. This and that cancel, and we just have negative x on the top over, bring that down to the bottom. Let me keep it as x squared plus 16 with that 3/2 power, but positive now. So when we apply integration by parts, first we do this times that. It has no integrals anymore. It's just the first part of the answer. So I'll do this times that, which is the same as this times the original. We get x over square root of x squared plus 16. And then we have to put these two parts together. And then that's still itself an integral. Now check this out. Negative times negative, so it's positive, right? Negative times this negative, yeah. And then x times x is x squared. It's itself an integral over this bottom, which is x squared plus 16 raised to the 3/2 power dx. So as you can see, if you just go through the integration by parts like this integral arguably is more difficult than the original one. But can we really continue from here though? We can try, and that's what I did. If on the top I add 16 so I can match with the bottom, of course I will have to subtract 16 right after. Have a look. This right here will give us the integral x squared plus 16 over this. And then we add negative 16 over that dx. And both things are inside the integral. Now, as you can see, this can be reduced out, so it becomes 1/2. So, and then let me break down the integrals. We have integral 1 over, let me write it with the square root form for the 1/2 power. And I'll close it. And then here we have minus 16. Let me bring that in the front, and the integral, and then 1 over x squared plus 16 to the 3/2 power dx. So have a look. This is what we end up with. Right? We have this. It's equal to that plus this integral and then minus this part. And let me just kind of organize everything nicely for you guys. Have a look right here. Notice here we have the original one, and on the right hand side we have the same exact one. So yes, we can just subtract them both sides. So this cancels out nicely with that, right? And now keep this in mind. When we subtract integral from itself, the result is not equal to 0. The result is technically a constant c. So let me write down c right here. However, truth be told, if you put down 0 right now, it will be fine because we have another integral in this equation. But let me just have that habit. This minus that, we get constant c. Anyways, this right here is equal to this minus 16 times that integral. Now notice we have this equation. Where's the original integral? It's gone. However, let me tell you though, if we isolate this integral, the result, it's actually just going to be whatever we get, and that's actually correct. So I think this is like the weirdest way to integrate this thing instead of the original one. I have no idea why that happened, but it did happen. So could I use integration by parts for the original? I don't know, but let me just finish right here for you guys. So let me bring this to the other side and divide both sides by 16. So we will get a positive integral 1 over x squared plus 16, 3/2 power. And I divide both sides by 16, so we have this over the 16 and then square root of x squared plus 16. And then you can bring the constant to the other side. So technically it would be a, okay, let's do that. It's like a C1. When I bring that to the other side, it's technically a negative C1. And then again, I divide it by the 16, right? So 1 over 16 like this. But C1 is a constant. Negative 1 over 16 C1, it's also a constant. So we're just going to label that as C2. And there you have it. This is equal to this thing plus constant C2. And then we're done. Pretty cool, huh?